Hello friends, we are looking into Introduction to Wave Principle. In the past videos, part 1 and part 2, we reviewed about motive waves and corrective waves. What are motive waves? What are the kinds of motive waves? And corrective waves, what are the kinds of corrective waves? What are the rules for motive waves and corrective waves? Those principles, rules will help us to identify waves in the past with the past price. But what are we going to discuss today? In this video, this is the part 3 and the final video of this wave principle. In this, we are going to see a technique which will help us to predict or forecast future price targets with the technique Fibonacci ratios. And what is Fibonacci ratio? If you doesn't know, there are plenty of videos available in YouTube. You can refer it and understand Fibonacci ratio. Even I too published a video on Fibonacci. If you are interested, just review this suggestion section and go through that video and come to this video after that. And make sure to review the part 1 and part 2 as well to understand part 3. I captured this videos pretty short so that you can grasp the information in your leisure time. So why are we waiting? Sit back, focus and continue on this video. Price and time aspects of wave patterns often reflect Fibonacci ratios. In wave formations, the key Fibonacci ratio is 0.618, which is known as the golden ratio or golden mean. It is represented by Greek letter phi, pronounced as phi. Its inverse is 1.618. These numbers are significant. We need to make note of this number. Memorize this number or take a note of this number. We are going to use this number in our wave principle. If we square phi or subtract phi from 1, the result is 0.382, which is another Fibonacci ratio. Other important Fibonacci numbers related to wave formation are 0.5, which is 1 by 2, 0.786, which is the square root of 0.618, golden ratio, 1 and 2. In Elliott wave patterns, the key types of Fibonacci relationships are retracements, multiples and dividers. First, let us look into retracements. In the motive waves, if wave 1 is 100%, if we assume wave 1 as 100%, then the retracement will be 61.8% or 0.618. Similarly, if wave 3 is considered as 100%, wave 4 will retrace for 38.2% or 0.382. This is for impulse waves or motive waves. And for corrective waves, for zigzags, if A is considered as 100%, B will retrace 50 to 79%. For triangles, if A is considered as 100%, B will retrace for 38 to 50% in the case of normal triangle. If it is a running triangle, it will retrace for 10 to 40%. In the case of flat, A is considered as 100%, B will retrace for 38 to 79%. In the case of combination, if W is considered as 100%, X will retrace for 38 to 50%. Now we'll see about multiples. In an impulse wave, wave 5 will often equal 0.618 or 61.8%, or it can be 38.2% as well in this case, times the net distance traveled of wave 1 to wave 3. When wave 3 is extended, wave 1 and wave 5 will be of equal length. When wave 5 is extended, expect wave 5 in price terms to travel 1.618 times the net distance traveled of wave 1 to wave 3. If the length is exceeded, look for larger multiples. When wave 1 is extended, expect the net distance traveled of wave 3 to wave 5 to equal 0.618 times the length of wave 1. In zigzag patterns, either in single zigzag or multiple zigzag, the length of wave A equals length of wave C. Similarly, in multiple zigzag, length of wave W equals length of wave y. In case of flats, most of the waves, most of the time will be of same length. In case of expanded flat, expect wave C to equal 1.618 times the length of wave A. Here you can see wave A is assumed to be 100%. Then wave C is expected to have a length of 1.618 or terminate at a price equal to 6.618 times the length of wave A past the wave A. I'll repeat, it's little confusing. To terminate at price equal to 0.618 times the length of wave A past wave A. Expect wave B to equal 1.236 or 1.382 times the length of wave A. In case of contracting triangle, the alternate waves are often related to each other by Fibonacci ratio of 0.618. Here the wave A is 100% if it is assumed to be 100%. Wave C is assumed to have 0.618. Here if wave B is assumed to be 100%, wave D is assumed to have 0.618. If wave C is assumed to be 100%, wave E expected to have 0.618 or 61.8%. Now the dividers. If we divide any length in such a way that the ratio of the smaller part to the larger part is equal to the ratio of the larger part to the whole, the ratio will always be 0.618. This is smaller part, this is larger part, this is larger part, and this is whole. If we divide A divided by B, or if we divide B divided by C, we'll get 0.618, which is explained with this example. If we consider the whole motive wave or impulse wave as 100%, we can divide only the length from wave 4 to 5 as 0.382 or 38.2%, and from start of the wave till wave 4 as 0.618 or 61.8%. Or in the other way around, till 4 we can consider it as 38.2% and the remaining as 61.8%, or till 4 we can consider it as 0.382 and the remaining as 0.618, which explains the divider rule. Finally, we'll discuss about clusters. What is clusters? Whenever possible, we prefer not to rely on just one Fibonacci relationship in forecasting market movements. We as a technical consultants or technical analysts will expect confirmation in the market. Fibonacci by itself provides confirmation, which we are going to see right now with an example. Fibonacci price cluster occurs when two or more Fibonacci price relationships project to approximate the same price level. Here you can see the number within square brackets or higher degree of waves. Number in blue, alphabet in blue, which parenthesis is second degree of wave. The number that is marked in red or third degree of wave. Here for number 2 is measured to be 0.618 or 61.8% of wave 1. The second degree wave, which is blue ABC, is considered to be an expanded flat. C wave from B to C is considered to be 1.618 of A. The third degree wave 5, is considered to be equal size of wave 1, all ending up in a single target. 5, C, 2, all ending up in one specific target. Hence proved in this example that Fibonacci help us to set a target. Thank you friends. With this, with 3 parts of wave principle is coming to an end. In the next video, we'll discuss a new topic. Thank you for sticking till end of this video. Appreciate your time. Please consider subscribing to my channel. See you in the next video. Bye bye.